Well, hello there, how are you doing? Today we're going to read some educational materials, so I do hope you enjoy. It's gonna be so educational, it's unbelievable.
Alright class, alright, settle down. My name is Dr. Woman and welcome to Females 101, where we learn everything there is to know about females. Trademark. Did you know, class, that periods can be held in like pee? Yes, Timmy?
Dr. Woman, is it true that my balls grow if I don't pee?
Very good question, Timmy, and you're absolutely correct. Not peeing does make your balls bigger, so you should not pee if you want to increase the size of your balls.
Just kidding, it was me.
All along, who would have thunk it?
Dear God, that's so awful.
Well, good evening, laddies, lasses, and lassos. Welcome to the Click. You smell absolutely astounding today. And don't let anyone else tell you otherwise. Are you ready for some sweet old education? Who needs university and school when you can watch Click meme compilations? So anyway, today we're gonna do something absolutely beautiful. A plus B equals 3. A plus B plus C equals 6. And A plus B plus C times 4 is question mark. So here's an answer that says A equals 1, B equals 2, C equals 3, so the whole thing is 15.
You failed math. 1 plus 2 equals 3, 3 plus 3 equals 6, and 6 times 4 is 24.
Oh, so you messed up like the most basic of PEMDAS while still being confident, and 700 people liked it. 700 people were like, yeah, this dude knows what he's talking about. Booyah. Ladies and gentlemen, you know what it is time for? That is right, it's time for Click Academy. Whoa! Wait, I need to write it. I haven't written Click Academy. Hold on. Click Academy. Nice. Okay, so one thing with this problem. Let's just write it out to begin with. A plus B equals 3. Then we have A plus B plus C equals 6. And after this, we have A plus B plus, well, basically C times 4, which I'm going to write as 4C, equals question mark. So this is what we're looking for. We're trying to solve how much this is going to be total. One thing that stands out to me with this equation initially is that you can simplify this quite a lot. A plus B only appears as A plus B, meaning that this first equation, for example, can have multiple solutions. The person in the comments for this question concluded that A equals 1 and B equals 2, but the fact is that you can have any number of solutions for this. A can be 0 and B can be 3, and it still works with all of the equations. Or A can be 1, B can be 2, or the reverse as well. So the whole point is that A plus B always show up as a pair. So this whole thing is written more complicated than it needs to be. You can just conclude that A plus B total, we can just write it as Z, for example. And the new equations we get is Z equals 3, and then we have Z plus C equals 6, which in turn means that C is also 3, right? It's pretty simple. And then the last equation is just going to be 3 plus 4 times 3, right? Because we already have all the variables, which in turn is going to be 15. So I think one takeaway from stuff like this is that you can often make stuff much more simple than they appear to be at first. Like in this instance, there's no point in making it more complicated than it really is. A plus B always show up as a pair. So if you just replace them all with one new variable instead, you can solve this by only solving for 2 letters instead of 3, because the third one is just excess. It doesn't do anything. Thank you so much for showing up to Click Academy. One rule of thumb when it comes to this kind of algebra and stuff is that you can usually solve one variable per equation. If you have fewer equations than variables, you usually end up with what is called a parameter solution, which means that your solutions can be anywhere across a graph, basically, or a line, so to say, because you have multiple solutions. So this one is just unnecessarily written in a complicated way. A lesson in math is usually don't make it more complicated than it has to be. Pretty good takeaway. If everyone understood order of operations, this sub's content would drop by about 80%. r/its PEMDAS dumbass was created exactly for this. Wait, there's a whole subreddit for this? r/its PEMDAS dumbass? Math is hard.
That's not how it has ever been. Now parentheses work. By your logic, 2 plus 3 to the power of 2 would be 25. Hint, the answer is 13.
Which is, of course, demonstrably incorrect. Oh my god, that's beautiful. There's an entire subreddit for just this. Confidently incorrect is breeding into cute little offsprings. Isn't that gorgeous?
Anyone explain how does the mirror know that there's an object there?
Oh, okay. I see what the confusion is.
Look at this.
Oh my god.
How does the mirror know that that's there?
That's creepy.
Yeah, because the paper is in like the way of the thing, so the thing itself doesn't have a correct straight line to the mirror. The thing though is that it reflects in all angles, you know? So if you're standing here next to a mirror that is flat here, the bouncing can happen like this as well. Right? There's actually a picture of this in the comments. So let's do that so I don't have to draw it myself because my drawings are awful. Light reflects at the same angle from the imagery perpendicular dotted line. Angles may not be reflected perfectly because this is freaking MS Paint. The solid lines are the light that you see the egg. So you can see on the picture the egg on top of the paper is reflecting to the mirror and then to you. So you can think that if you can bounce something like a ball, doing doing, from you to something else in the room, that's basically the same direction that the light can bounce as well. So you're not seeing the egg because it has a straight line into the mirror. You're seeing the egg from the side where it's going slightly like this and then towards you from the mirror. That's how the light is bouncing from that piece. But it also feels like such a trick question, doesn't it? Like if you haven't drawn these kind of things in school or in physics, like it's such a trick question. Like how can it be there? Like there is nothing here. The paper is in the way. The mug shouldn't be able to travel here to the mirror. But you know, it's just traveling to the side of it and then the light is bouncing into your eyeball. So that's how it works.
If the statement trans women are women were true, the statement women are trans women would be equally as true. But virtually no one thinks or says that. Just an observation.
All yellow cars are cars. Not all cars are yellow cars. It's pretty simple to make up a very basic example of like subcategories of larger groupings of things. This is so stupid. Should we draw a Venn diagram? Let's draw a Venn diagram. Paint, please! Laddies, lasses, and lassos, welcome once again to Click Academy, where we can't spell, but that's okay. So today we're investigating like subgroupings of categories. So imagine you have a Venn diagram that looks like this, and you have like a group inside of it that is more specific. You know, this can be anything. This can be, for example, women, trans women, or it can be cars and yellow cars. It means that this one is a part of this one and has the same kind of definition on a broader level, but it doesn't mean that this one is automatically this one. It's a subgroup of a larger category. You see? It's a surprisingly complicated concept for some reason. Thank you so much for listening to Click Academy of me drawing circles. Gandhi came to London in 1888. Jack the Ripper started his killing spree in 1888. Gandhi returned to India in 1891. Jack's supposedly last murder was in 1891 as well. Jack's identity was never found out. Jerry will be back tomorrow with more disturbing facts. You see, everyone, it's very important to differentiate between correlation and causation. And if the internet is to believe everything is a causation. Every single thing. Everything caused everything. Welcome to Click Academy evil version. I wonder if people would pick up on that. Should I do that for like, you know, April Fools or something? I just have a Click Academy that is just grossly incorrect? Or will enough people actually still believe it that is just a bad idea? Is this just my villain arc to becoming a crappy TikTok prankster? Oh no. All right, class. Settle down. My name is Professor Gherkenstein, and today we're gonna learn about social etiquette. So I'll do this with math. I'll mathematically prove this to you. On this axis, we have confidence. I can spell, trust me. On this graph, we have incorrectness. And you do not want to be here, which is what we call the confidently incorrect area. I mean, it's also pretty to be down here, I suppose. But don't be here. That makes you insufferable. You're supposed to be lagom. Bli lagom. Lagom. So here you have a bunch of buff dudes. There's 15, and then 9, then 18, then this. Alright, so what should this be? It should be 5, 3, and 6. But you have 2 of the 6s. That's 12 plus 5, which is 17, and then plus 3, which is 20, I guess.
It is simple. Divide 15 by 3, 5. Divide 9 by 3, 3. Divide 18 by 3, that's 6, it's 14.
But there's 2, I mean, it's a silly quiz in the beginning, but there's 2 of the 6s, though. So, no. It's important to read the question, kids. I mean, you had the calculations completely correct up until the last point, and then you just decided to call everyone an idiot. The frick is the answer? Coca-Cola plus cola is 30. Cola plus hamburger, burger, 20. Burger, fry, 9. So the Coca-Colas are 30 combined, means each cola is 10. 10 is actually 2 burgers, so that means a burger is 5. So then the fries should be 2. Alright, so you have a burger, that was that 5 or whatever, and then we have 2 and 10. 17? Is that it? Alright, genius. You know what I hate about these puzzles? They don't actually teach you the actual method for solving things like this because they always give it away with the first formula. Let me show you what I mean! Click Academy time in Paint! Woo! Alright, welcome to Click Academy, everyone. We're gonna do math. It always is fun. Math. Smiley. So there is a rule in mathematics that you can solve as many variables as you have equations. So for example, let's say you have 2 variables, x and y. You need 2 equations to be able to solve for these variables, otherwise you will get what is called a parameter solution, which means that one of the answers could be anywhere across basically a straight line, and then of course depending on how many variables you have, but that's generally called a parameter solution. So let's say for example we have x plus y equals 3, and then you have, for example, 3x plus y equals, like, I don't know, let's just pick 6. This is a bit trickier than that hamburger thing, because now all of a sudden you realize, wait a second, how do I solve this? I can't break anything out of the first equation, I can't break anything out... let me move this down. Oh, there we go. Professional. I can't break anything down in the second equation either. How do I solve this? Well, a trick to solve this kind of thing is either to just take this entire thing, times minus 3, and move it down to cancel out the x. Or if you want to do this more simple, you can, for example, rewrite the first equation as x equals 3 minus y. Then you put this bad boy into there. And then you can solve this entire equation, because then at the end of this thing you will only have y's. So you will actually get 3 times this x, which is 3 minus y, and then plus y, equals 6. And a bit of brain gymnastics here. Let's see now. So this will be 9 minus 3y plus y equals 6. And this means that we can break out y, because we have minus 2y here. Let me do this a bit less cluttery. So then this equation, we can solve this bad boy. And we can, for example, take y to this side. So we have 9 plus y equals 6 plus 3y. And then we cancel this out, so we have 9 equals 6 plus 2y. And then we just like take minus 6 on both sides, and 3 equals 2y, and y is equal to a half. Yum! And then to solve the other thing, of course, you just squeeze this bad boy into here. And then you get that x is also a half. No, x is 2.5, sorry, wow, I'm a boomer. Which means, this in turn, let's do the equality things here. Ah, there we go, that means that x is 3 minus a half, which means that x is 2.5. So this is how you solve it when you... What a freaking mess. This is how you solve it when you don't just have the first line giving you the answer to what x is. So you can actually use all the equations to your advantage, and for each equation you can solve one additional variable. If you have x, y, z, you need 3 lines of equations to properly solve it. Anyway, that was Click Academy Math. Beautiful! Moving on with rest of godforsaken video. Oh, look at this math thing. The equation is 5 plus 1 multiplied by 10. Oh yeah, I guess that, okay, so we have a bunch of stuff equals 30, so that's just divided by 3 obviously, so 1 cup is 10. And then we have 10 plus 2 burgers is 20, so it means that, you know, there's 10 left, 2 burgers, so a burger is 5. Oh, here's where the tricky part comes in. You see there are multiple fries to like fry your brain a little bit. So if a burger is 5, that means we have 4 fries is worth 4, so fry is 1. And then at the bottom, there's a little multiplication sign as well, so this is just a question that seems a little bit tricky. So we have 5 plus 1 times 10, which is 15 if I'm not mistaken, which seems to agree with the caption. Very cool. I'm so glad we could all agree on this. No one could possibly disagree with this basic math. 25, order of operations. I was sorely mistaken. Thank you, Blorp, for proving me sad. It's just a problem being sneaky and trying to catch the person reading it off guard with the one there being 2 fries in one slot, but the other it's only 1. I also thought it was 25 till someone pointed out that there is only 1 fry in that spot at the end and that there is 2 in the other. Yeah, I've seen problems like this before. I think I've even failed a couple in videos because they like hide sneaky things in the images that you don't think about. So okay, maybe my hope is slightly more restored. I am part of the stupid and that makes it okay. Today, let's talk about the radical speed changes that would occur if we were actually living in a heliocentric model. Okay, we're going to deal with the slowest 2 of 5 simultaneous motions being claimed. One is the rotation of Earth's speed, and the other is the speed around the sun. At night, the rotation of Earth is going with the motion around the sun. What? The forces are acting in concert? 1040 miles per hour plus 67 miles per hour is 68,000. During the day, the rotation of Earth is acting in opposition to the motion. Wait, are you saying that, you know, during the day, it goes like this and spins around the sun, and then during night, just... That wouldn't make sense. Then the day would just restart. You realize that, right? Like, the light comes from a direction, and if you just did this, there would never be nighttime. Like, if it started spinning the opposite way, then the day would just, like, go backwards, sort of. What? Am I understanding this correctly? This is bonkers. During the day, the rotation of the Earth is acting in opposition to the motion around the sun. Okay, minus 10. What? But then they're adding it together, so it's still like... That's a speed change of 2,000 miles every single day. Well, because it doesn't... What? What effect do you suppose such a radical change in speed would have on standing water? That's right, it would sloosh violently out of place every single day. Oh, you have done this experiment at home where you like have a glass of water and you do this. Does it? No, it doesn't. Do you know why? It's actually very simple. The heliocentric model is false. It's always been false. In actual reality, you live on a stationary plane. Thank you for listening. Have a marvelous and motionless day. Rotation of Earth, centrifugal force, gravitational force. Wait, is this also saying that we should be like tossed out into space with the centrifugal force? Oh my god, that's amazing. That is amazing that like the gravitational force is towards the sun primarily and not the Earth if you're standing on Earth, and the centrifugal... That is so weird. Wait, or are they talking about like rotational speed around the sun? Because like stuff is kind of elliptical in a lot of cases. So is that where they got the numbers? But like just completely misinterpreted what they mean? That's entirely possible, I suppose. Okay, but that whole thing made me intrigued, though. That whole thing made me intrigued. Like, can we be launched into space because the Earth is spinning? You know? If the Earth is truly spinning, why aren't we just being tossed into space with a centrifugal force? That is why on today's Click Academy, we are looking at this little Earth, which I'm gonna denounce really pretty in correct Swedish spelling. So here we have our very good home planet. This is Earth. Everyone loves Earth. And if you're standing on the top of Earth, like a happy little feller that you are, wow, look at that. You're so happy. You also have cat ears because you're a viewer of the Click channel. Anyway, with this whole idea, right, you have one force pulling you downwards, which we denounce Fg, which is your gravitational force, and a force upwards, which is your centrifugal force, which we will take as Fc. So, according to this argument, right, the Earth can't be round because when it starts spinning, you would be launched into space. Like, that's kind of funny. I like this argument. So, for that to physically happy to launch out this person with the cat ears and stuff into space, this force would need to be bigger than this force. So is Fc actually larger than Fg? We'll find out together, shall we? Fg is very simple. That's just your mass times gravity. So for me, for example, as a little Swedish feller, I weigh about 80 kilograms. The gravitational constant is like 9.81 or 82, something like that. So we'll just say that this is 800 Newton roughly. That's cool. That's how much I'm getting pushed into the ground. Wow, I feel heavy already. And now we're gonna have a bit of a color swap for pedagogical reasons. Fc equals your mass times the velocity you're going forward. Your velocity is like this. Yippee! That's v. So v squared divided by r. And you see, this is why Fc becomes kind of tiny, because the Earth do be big, y'all. So this for me would be like 80 kilograms. Oh no, they're supposed to be squared. Why is my dyslexia writing it like a 1? This is why I failed so many tests in uni. Dear God, Click. That was like a brief upbringing of trauma, my God. And the velocity is a total of 460 meters per second. squared. And then we divide that with the total radius of Earth, which we also have to be in meters, because otherwise the dimensions are going to be all messy between this number and this number. Oh dear God, that's a big number. Okay, so the radius is 6. So this is going to be the force that tries to yeet us out into space. I'm gonna cheat and do this on my calculator. I'm not doing this one in my head. 2.65 newtons. I'll write my n right there. So you can see this force, if my calculation is correct, is very much smaller than this force. So conclusion is you wouldn't feel this at all. The centrifugal force that you feel from the Earth spinning is basically negligible. You would never feel this. It's like, hundreds of times smaller than the actual gravitational force on your little body. Thank you so much for showing up to Click Academy to debunk why we don't get yeeted into space by the Earth spinning. But I mean, maybe they would just say that gravity isn't real. In that case, oh no, then we would all just lift very slowly off the ground because it's not a big force. We're just like, oh no. X plus 2 equals X minus 2. Find X, 25,000 likes. Oh my god, it's TikTok math. Let's get into it, shall we? So the person solving this have moved X plus 2 inside of parentheses to the other side. So, okay, equals 0. Yeah, that's not how you do it at all. It would be division probably, and then it would be equal to 1 anyway. And then you have x2 minus 2 squared, which is 0, but it's based on a false principle to begin with. And then you just simplify it and realize that x is either equal to the square of 4, or x is equal to minus the square of 4. Easy! Okay, that is just monstrously incorrect. There is actually such an answer in math that it's undefined. Some things don't have a solution. Let's actually get into this, because this is an interesting thing. I think they sort of gloss over a lot in various educations, and I think it's important to show it both like in numericals, but also graphically. So let's do that together, shall we? Welcome everyone to Click Academy. We don't need real school when we have Click Academy. So today we have a beautiful little equation that I'll put on my second screen. We have, I'll just remove this because you can't read it anyway. So we have x plus 2 equals to x minus 2. So of course, if you wanted to solve this equation, right, you would like remove x from both sides, like minus x on both sides, and you get 2 equals minus 2. Which is kind of weird, because this ends up being like 4 equals 0, which is obviously not true. So this means that the equation doesn't have a solution. If you simplify it enough, you get 4 equals 0, which obviously isn't the case. So one way that you can show that this actually doesn't have a solution is simply to draw it. Because any equation can be drawn graphically as a curve or a line, and that is exactly what we're going to do here. We're going to write it like two curves, y1 equals x plus 2. And the second equation, we will call y2, is equal to x minus 2. So instead now of having this part equal to this part, we have just formulated them like two curves instead, and we're gonna draw both and see where they're intersecting. Because where these two intersect is where you would have the solution of x, so to say. So we can start off by the curve at the top, which is y equals x plus 2. So if x is 0, y is gonna be 2, which means the curve crosses the y-axis over here. And because you have a multiplier of 1 in front of the x, essentially, it's just gonna go kinda like this. My little beautiful hand-drawn curve. This one, on the other hand, this curve here, now checking where they intersect, when x is 0, y is gonna be minus 2, meaning that it's gonna intersect down here. But the steepness of the curve is identical to the first equation because you only have a 1 in front of the x, meaning that the curve is gonna look like this. So as you can see here graphically, the curves will never actually intersect, meaning that these two equations don't have a solution. They never cross each other, they never have the same value, meaning that if you put this equation up here equal to this equation, it wouldn't work. They don't have a single intersection, meaning no solution. Thank you all so much for showing up to Click Academy. You can buy your buy your diploma in the description. Wouldn't that be amazing merch though? Maybe I should make that as merch. That'd be so cool. Homeschooling should largely be illegal.
We will teach our children that people like you deserve to be hung, and you cannot stop us.
Hanged. Isn't that great? Calling for violence and people with different opinions to be hung, but you can't even get it grammatically correct.
We wish for all people like you to be hung.
You know that means that you just wish for them to have big pee-pees, right? That is absolutely astounding. Thank you so much for today's grammar lessons. Click Academy is amazing. Next post, please. For those who love calculus, df dt limits age goes to 0, ft plus age minus f of t divided by age.
So much in that excellent formula. Don't let the DEI folks mess with it.
What on earth are they... Dear... Welcome, ladies, lasses, and lasses, to Click Academy. So today we have a very exciting formula on our hands, baby. Oh, yes, indeed. I'm actually just gonna take a screenshot of this. Why not? I'm not gonna bother writing this. I can't write. So we have this beautiful formula right here, which is basically the definition of like how fast something changes on a curve. So if you were to explain this in a super simple fashion, you would have like a two-dimensional curve like this, and you have f of t up here, which is whatever function based on time that you want. It could be like the speed of a car, or the location of a planet, or like whatever, anything that is affected by time. And on this curve, you would have the letter t. And then you have a curve that does something like this, like whatever. And then what this formula means is that you pick any value of t, right? We could pick, for example, here. Here's the value of t. And what this formula does is that it calculates how steep the curve is on this infinitely small point. So if we look here in the formula, this part of the equation and this one will basically be infinitely close to each other because age is infinitely small. And this one will also become basically infinitely small. That's the whole point. And this part of the function here, df divided by dt, is just the derivative of the function f in the t dimension. As you get into more math and more dimensions and stuff, you could do this with basically any variable. One really fun thing that you start doing in multivariable calculus is having like multiple derivatives in multiple dimensions, that when you get like these weird 3D fields of like stuff leaning everywhere. But anyway, so this means that this formula would calculate like how steep the curve is at this specific point, you know, which in this case would probably look something like that, depending on which formula we have. All right? So that is basically how this thing works simplistically. So whatever these people are talking about on Twitter is ridiculous. It's the kind of like bogus, buzzwordy talking stuff that looks complicated and smart if you haven't specifically studied this kind of stuff in school or don't remember what it stands for. But if you know what it is, the whole thing looks really silly from an outwards perspective, because it's just like, ooh, this little curve is this steep at this point, and here's the definition for that. You know, talking like this about like, oh, this beautiful formula, don't make it woke. What are you talking about? What? So I hope you enjoyed this episode of Click Academy. Leave a like on the video if you want more Click Academy, baby. But why the frick is everyone telling me numbers are Arab? I mean, like 1, 2, 3, 4, 5, etc. Arab people write it like this. Just looked it up. So please educate yourself before trying to lecture me. I swear, you single-handedly bring down the average IQ of our entire country. Here is a Wikipedia link. Please educate yourself a little further. The numbers that Europeans and Americans use are called Hindu-Arabic numeral system. That numerical system has different branches. What has me so concerned is that 162 people liked this initial comment. And it's pinned by the author. No. One really interesting thing with human history is to look at how information has evolved throughout the centuries. In the beginning, the problem was that there wasn't enough information out there, or simply that people didn't know how to take information on board. For example, literacy was pretty low. How do you spread information if no one can read or write, and you don't have the internet and you don't have TVs or whatever? And then as society evolved, we eventually reached the point today where information in of itself is so incredibly abundant, but the problem becomes filtering out the good information from the bad information. And this is certainly one example of it. You have so much noise and so much algorithms and everything just feeding you constantly. And how do you even make sense of it? And sometimes it even creates fallacies in how you interpret information, even if the information itself isn't actually false. So welcome to Click Academy. There we go, doctor's handwriting, that means I'm smart. So one common fallacy, for example, when it comes to media consumption, even though the thing you're consuming in of itself isn't actually false, is your sense of how bad the world is. That is not to say bad things don't happen, they certainly do, but a lot of things in the world, minus, for example, the environmental crisis, are gradually getting better as the year progresses. But if you look at a graph, for example, take a subject on this axis that is something like child mortality rates, for example. Typically, they have gone down over time. But then, for example, there's occasionally like, oh, there's a bad news, there's a disease that hits or COVID or what have you, and then it keeps going down. But during the news cycle in this area where we find ourselves at a current state in time, if this graph is T, for example, is that it will feel really negative because, oh my god, child mortality rates are shooting through the roof, everything sucks. And that doesn't mean that it doesn't happen. These are real people suffering, and that is important not to forget. But it's also important not to get yourself paralyzed by negativity, because if you zoom out, you'll see that, oh my god, it's actually getting better over time. I think it's an important thing to realize when you're consuming news, and especially nowadays where you even have social media where a lot of the things travel because they are inherently rage-baity, negative, or very crisis-oriented. It is psychologically proven that humans are more likely to click on or engage with things that are negative or shocking. I think a good way to think about stuff like this is realistic optimism. It's like, bad stuff is happening, it is still happening, the world is a horrible place, but it's a little less horrible than it was a few decades ago, right? And that has been the typical trend for a lot of things, and hopefully it keeps being the case. So it's important to see the world for what it is. Negative things happening. We are currently finding ourselves in a time where a lot of negative things are happening. It's a lot of uncertainty, but it's also good to look at the world throughout a wider scope. And there are a lot of fallacies when it comes to this kind of stuff. And this is only the fallacies when it comes to like news that are inherently correct in of themselves. This is more of a psychological fallacy in humans. And then you pair that with all the misinformation that is floating around, and yippee-hoo, no wonder frickin' social media looks the way it does. Holy fuck, man. Another thing to look out for in social media, and this is important also to look out for example, if you have younger siblings and the like, is how quickly you can get sucked into rabbit holes of extremism. And this is often because a lot of spokespeople for very extremist things online say things that are, true in the beginning. It's like stuff that is sprinkled with truth, but then it becomes this massive black and white worldview very quickly down the line, and it just becomes absolutely unhinged. Are any of them qualified in maths? 50 tabs? Ooh, 60 tabs. It's 50% more. 50% more than what? Just saying 50% more is meaningless. Do you know how many millions of dollars I have? 50% more! 50% more than 40, of course. Actually, when someone starts off with actually, it's not gonna be an actually. 50% more than 30. 60 divided by 2 equals 30, so it's 50%. Why was I born a human and not something fun like a fucking squirrel? Next time, don't make math jokes unless you're actually confident in your answer and have double-checked with a calculator. Edit. Damn, so many math whizzies trying to correct me who clearly don't know how to use a calculator. Lol. Makes me sad for the public education system. I love this kind of person because they literally took all their stats out of intelligence and pumped it into confidence. It's amazing.
Are we really gonna do a Click Academy? Okay, wow, it's gonna be, oh wow, 2 + 2 is 4, am I right?
Alright, welcome to Click Academy. So are we just doing Click Academy about like stupider and stupider things? That's certainly what I feel like. Even Click Academy is regressing. This is sad. Okay, so if you have, for example, 50% of 60, that would be the same as doing 0.5 times 60, because it's half, right? Which would be 30. But if you want a 50% increase of something, for example, a 50% increase of 30, you would take 30 multiplied by 1.5, because this would be 150% of the original, which is then a 50% increase, which is 45, okay? So you can't like use the same percentage in both ways, right? To get back to the original number that was cut in half, you need to obviously double it, right? So 30 times 2, which is then 200%, would be 60. So it's all about like what the original number is. That's sort of the trick about percentages. Thank you for coming to my Click TED Talk. Do you pull the lever, killing 1 + 1 + 1 + 1 people, 1 person for every integer, resulting in infinite people dying? Or do you do nothing, allowing the trolley to infinitely kill 100 continuously reincarnating people? In both cases, there is infinite suffering. But in the top case, there is finite suffering for each infinite death, whereas there is infinite suffering for each finite death. What do you do? Only -1/12 of a person would die on the top route, so I'll do that one. Yes, indeed, I see where you're coming from. Very smart there, fellow mathematician. It's a very memed mathematical problem that this infinite series becomes -1/12. So in this problem, if you pull the lever, you will kill -1/12 of a person. So you will actually save 1/12 of a person somehow. And the reason this becomes a bit wacky mathematically is that this comes from something called the Riemann zeta function, which is a series that looks like this. The problem is that this series is only really defined when RE of S is greater than 1. This means that where this series is not defined, or it becomes divergent, meaning it just goes towards infinity, basically, you use something called analytical continuation. In complex analysis, meaning that when you have a portion of a number that is imaginary, or I, which essentially is the root of -1, a branch of mathematics, analytical continuation, is a technique to extend the domain of definition of a given analytical function. So for example, if you have a function that isn't defined, take a very simple one like 1 divided by x. If x is 0, this becomes, a little bit undefined. It just say, bajunga! And the same thing is true in this instance, right? Analytical continuation often succeeds in defining further values of a function. For example, in a new region where an infinite series representation, which initially defined the function, becomes divergent. The stepwise continuation technique may, however, come up against difficulties. These may have an essentially topological nature, leading to inconsistencies. They may alternatively have to do with the presence of singularities. So basically, saying that this technique can have difficulties. I actually found a very nice little animation on Reddit for this specific problem. I'll link it down below. But it's this little video that shows like a 3D graph of the Riemann zeta function, and you can see where it's starting to diverge, kind of. Displayed in a very nice 3D way. And this of course means that because of the original function being assigned a value where it's basically undefined, or divergent in this case, means that this methodology gives very wacky answers. It doesn't actually mean that, this series of infinite people would be -1/12. So that's like the layman's terms of it, I suppose, but I'll leave all the links in the description if you want to read more about it, because math do be fascinating and funky sometimes. Okay, so anyway, no, I wouldn't pull the lever because we're gonna kill -1/12 of a person. Okay, next argument. Are the 1 + 1 + 1 people pulled from Earth's population? Because if so, the answer is easy. Sucks for those 100 people, but at least humanity won't go extinct. Do we actually kill people that fast? Hold on, this is interesting. Do we actually kill people fast enough to wipe out humanity if we do pull the lever? Okay, this is time for some Click Academy, baby. Alright, everyone, welcome to Click. We'll spell it like A dot, that's perfect. This is Click Academy for the trolley problem. Now, the question here that we want to investigate is if this top track will actually wipe out humanity, because then it's gonna make the choice pretty easy. Like, if this wipes out humanity, you're gonna choose to not pull the lever even if it causes infinite suffering, right? So that's what we're going to investigate. So to start answering these beautiful problems, we need to figure out how fast the trolley is traveling. And by a quick Google search, I found out that speeds can vary from 80 kilometers per hour at longer distances down to 50 in built-up areas and 15 through pedestrian areas. The average speed is actually about 20 to 25. But I'm going to assume that this trolley is like going max speed because it's just one long straight line. So we're gonna assume the max speed in this, which in this case is 80 kilometers per hour. And it looks like the distance between the people on the track, I would say it's like 5 people in between everyone. So every single person will have a distance of 5 people's widths, right? And if we Google like average shoulder width of people, it is apparently 41 centimeters for men and 36 centimeters for women. So this means that the trolley will have to travel 6 average widths of a person for every person it kills, due to the gap in between the people and the width of the actual person. So this would be typically 41 centimeters plus 36 centimeters because of the average, and then we divide this by 2 to get the average between them and multiply it by 6 because the gap is about 5 in between them plus 1 person's width. So this is going to be the total amount of distance in centimeters the trolley will have to travel to murder one person, which would be 231 centimeters. So this is the distance the trolley have to travel for every kill it gets. Man, it's going to be a good KD for this trolley, hell yeah. And we know that it travels by 80 kilometers per hour, so this is gonna be like 80 times 24 to get how long it travels in one single day. 80 multiplied by 24 is 1,920 kilometers traveled. Isn't that absolutely amazing? So to keep this consistent, this is very important when you do this kind of math things, I'm gonna translate both of these into meters. This one is obviously just multiplied by 1,000, which is 1,920,000 meters. That's how far the trolley travels in one single day. And for every, well, this is basically just divided by 100 instead, so this means that for every 2.31 meters, there is gonna be 1 kill. So from here the problem is relatively simple. We just need to divide this number by this number to get the total amount of kills per day. So that would be this whole number divided by 2.31, right? And that means that every single day the trolley is gonna murder 83168, which is 131,000 people every single day that this trolley is just gonna completely splatter. And if we look at how many babies are born every single day, not accounting for how many people die or whatever every single day, it seems that more than 367,000 babies were born each day. Okay, so we're gonna murder more than double of the amount of babies born every day, which means that sadly, to maintain humanity, we would have to not pull the lever in this case. I think that's a pretty reasonable conclusion. Morality is kind of out the window if humanity no longer exists. So I would say math wins again. I'm not gonna pull the lever. Sucks to suck 100 people, but you will suffer infinitely so humanity can go on, baby. The gambling trolley. You have a 1 in a 50,000 odds of winning $10 million. Each lever pull costs 10 cents. That sounds really cheap. How many times are you pulling? Don't worry about your family on the tracks. They're not your problem. The trolley can take you home whenever you're done playing. Hold on, wait a second. So 1 in 50,000. Does this actually make sense? Hold on, Click Academy. Here we go, baby. Okay, these numbers kind of stand out to me. So here's the trolley problem, right? Like this is the gambling trolley problem. What we would want to do in this case, how you do like an expected value, is that you have like the sum of, for example, you know, probability 1 and then whatever letter you want to use for like the quantity, right? We can just call it like K1. And then we have it plus probability number 2 and K2. So in this case, probability 1 and K1 is like how big of a chance do we have of winning the lottery and how much do we win, versus how big is the chance to not win the lottery and how much do we win then. So that's going to be our total expected value. Okay, let's write it down here so it's actually visible. So this in reality would be equal to what's the chance of us winning, which is 1 divided by 50,000, multiplied by how much we win, which is $10 million. So it's 10 and then 6 little zeros. So this is like the chance of winning the jackpot plus the chance of us losing, which means we win 0. So this is just going to be like, you know, 1 minus this. 1 minus 1 divided by 50,000, which I'm not going to write out because it's multiplied by 0 anyway, so it doesn't matter. So this one just disappears. So our expected value of how much we win per pull, on average, if we just do an infinite amount of times, it's going to be this, which is essentially equivalent to, I'm not going to do this in my head because I'm not a massive masochist. So the expected value is $200. This is a lottery that you don't actually even lose money if you keep gambling. You're going to get, on average, $200. Every time you pull the lever. Man, I would just keep pulling this thing. This is not even a question. If we're gonna make a gambling example, at least make the house win. That's how gambling companies and casinos work. But in this specific case, yeah, we just keep pulling that thing for infinity. Free money, baby. Hell yeah.
That is not, nor how it's ever been, how parentheses work. By your logic, 2 plus 3 to the power of 2 would equal 25. Hint, the answer is 13. I have a mathematical brain. You see, kids, welcome to Click Academy. Pretend I have a whiteboard here. So if you have a parentheses, right, and you have 2 plus 3 inside the parentheses and the power 2, everything inside the parentheses counts as a singular number, because you do the parentheses first. Hence, the answer is 25, and not 13, believe it or not. What? Someone would do that? Go on the internet and tell lies?
6 divided by 2, parentheses 2 plus 1 is 1. 6 divided by 2, parentheses 2 plus 1 is 9. Oh god, it's this one again.
It literally hurts me to see people saying it's 9. The answer is 1. Brackets first.
Oh yes, we have a little PEMDAS argument. I see this exact math problem go viral at least twice a year. It's fascinating. But under this post, it was actually linked a tweet from Matt Parker, which is really good at explaining this kind of thing, right? So I'll dig into this a little bit because it's so fun. 6 divided by 2, 1 plus 2 is going viral again. And the correct answer from a mathematician is you need to write this better so it's not ambiguous. PEMDAS, or BODMAS, is not some law of maths. Order of operations are a convention to make writing clear. P.S. The solution is always more brackets. I think this explains my frustration with this little math problem so beautifully, because it's two problems, right? One problem is that the first question is a bit ambiguous, and depending on like your school of math, you're gonna interpret it a little bit differently, because different countries do slightly different quirky things with signs and whatever. And the second frustration is that people are constantly quoting PEMDAS like it's some kind of rule of math. But it's not. It's a rule for memorizing basic operations in simple algebra. But it's not some kind of rule. Actually, Click Academy, let me show you what I mean, because I have a pretty good example that I think will explain this in relatively, like, simple terms. Alrighty then, ladies, gents, and non-binary fiends, welcome to Click Academy. So, I have a pretty nice example for, like, ranting a bit about PEMDAS and order of operations and that kind of stuff. Imagine we have a very simple equation. It's like x plus, let's say, 8x divided by 2. And to solve this one, you obviously want to divide this section first, right? Just to simplify this equation, which would mean we have x plus 4x, which is 5x, right? Pretty simple. Another way you can actually do this is, instead of dividing this first, you can actually transform this portion over here to have the same base as this one, the same denominator basically. So instead, we multiply the top and bottom of this x by 2. This means that we get 2x divided by 2, which is the same as x, right? And then we have plus 8x divided by 2. So what you can do now, which is a very quirky thing, is because they have the same denominator, you can actually add them together, which is what you do in regular addition as well, just that the denominator is 1, you know, so you don't actually write it out. But here we go. So this is actually going to end up being 10x divided by 2, which is 5x. What I wanted to show with this very simple example is that in some areas of math, or when you do calculus or algebra, for example, you sometimes expand portions of an equation so you can add it together because your denominator is the same. So in this very basic example, here in the bottom, I actually do an addition before I do division, basically breaking the rules of PEMDAS. But this is still proper math. This still works because you have, like, the common denominator here, the kind of hence the saying, right? And there is nothing in PEMDAS that says that, you know, oh, you have to do division before addition unless you have a common denominator, because then you can smack it together and bada bing, bada boom, you know? So the problem with PEMDAS that I have had isn't that it's like necessarily a bad rule for just remembering things. You know, you're helping your kid and you haven't done math in 15 years and you're rusty, and it's like, okay, wait, which one came first? It's like, okay, good, yeah, division. Of course it's helpful. It's a rule for remembering things about algebra and calculus, but it's not like a rule of math, right? It doesn't trump other things, and that becomes very apparent when you start getting into like more advanced math and that sort of thing, right? You don't really quote PEMDAS like ever. Oh, and also I suppose that if you want to rewrite that initial equation, let me just erase all of this. Sweet knowledge begun. 6 divided by 2 parentheses 2 plus 1. That was the one, right? The problem here is that it's so weirdly written. Like, some people would say that, you know, division or multiplication, one comes before the other because of PEMDAS, but that's not really the case. Multiplication and division is essentially the same thing. So then you would go from left to right. But the problem is that it's so ambiguous and it will confuse people on purpose. The proper ways to write an equation like this would be either to write it like this, 6 divided by 2 parentheses 2 plus 1, or how some people interpret it would be 6 divided by 2, and then the parentheses 2 plus 1. These are basically the two ways that you could, like, write this one in proper ways. And in any kind of reasonable math book, any of these instances is how you would actually write it. Either option 1 or option 2. You know, you would never write it like this first example because it is confusing and ambiguous on purpose. I would still argue there is kind of a right answer, but the problem is it's ambiguous and it's weird, right? And it's confusing on purpose, and that's why it goes viral, because it's kind of like a little bit of a rage bait. But the only reason it goes viral isn't because it's a fascinating math thing, it's because it's just poorly formulated. And even as the original post points out, there are even different generations of calculators that prioritizes different things first. Like, an old calculator might take the division or the multiplication first, even though in real math they are the same thing, essentially. That was a nice little side tangent. I think we all learned something. Screw this little math problem. Sending a cloud back to the sky.
Recording yourself. I don't know what you think you're doing, but you don't know how to operate the phone.
Good. This has to be staged, right? This has to be staged. Is it? I'm like 50-50 to the stage now. This is the funniest thing ever. Oh my god, that's amazing.
Sending a cloud back to the sky.
Oh, look at that. It's a tame little cloud.
A cloud can weigh 500 to 1,000 pounds. Just search how much does a cloud weigh.
It's literally smoke. How does it weigh something, little bro? Praying emoji.
It's not smoke. It's water.
Okay, well, water still doesn't weigh anything when it's just floating.
Let's see. Where did the pen go? I yeeted it at some point. Where did it bounce off to? Damn it. How am I supposed to do Click Academy when I can't write? Alright, class. Imagine that the little gaycation emotional support demon is floating on water. How much does it weigh?
The gaycation doesn't weigh anything because it floats.
That is absolutely correct. Whoa!
Ah, I love science.
Well, laddies, lasses and lasses, I hope we learned something beautiful together here at Click Academy. It's an amazing day, isn't it? Anyway, I do hope you have an amazing rest of your day. And I'll see you again in the very near future. Remember, we have Tiny Emotional Support Demon and Mungo coming in the very near future. They're super cute, super squishable. And if you get both, you'll probably have a little bit of percentage off as well. Hopefully, we'll see how all that works out. I will see you in the very near future. You wonderful beings. Take care. Mwah.
Oh, can I put like a little demon up here?
Oh, can it like look up in the corner? Come on now. Come on, baby. It's gonna take a while, isn't it? Gotta tape it, maybe? Maybe I can just hang it. Hold on. I'm end up breaking my whole setup, aren't I? Great, you can only see the keychain part. Nice. Well, laddies, lasses, and lasses, I do hope you enjoyed this video and that you learned something. The most important thing on this channel is education and knowledge. There's nothing more attractive than a big, veiny, throbbing brain. Thank you so much for watching, and I'll see you again in the very near future. Take care. Mwah.